Hey everyone, welcome back. Today let's solve the problem linked list cycle. We are given the head of a linked list and our task is to determine if the linked list has a cycle. We will return true if there exists a cycle and false if we do not find any cycle. The definition of a cycle in a linked list is that from any point in that linked list, if you keep following the pointers forward from any given arbitrary node, you will find yourself returning to the same original node that you started from. This can be repeated an infinite number of times. As you can see, if you keep following these pointers forward, you will eventually find yourself repeatedly getting back to the same old position that you started at. So the first thing that you need to note is that whenever there is no cycle in any linked list, the final or the last node in that linked list will eventually point to null. So in this case, let's assume that the final node with value 4 points to null, and that will mean that there is no actual cycle in this linked list. In that case, we can return false. However, from this example, we can see that there is an actual loop that comes from the value -4 up to the value -2, and it is repeated across an infinite number of times. So if a linked list does not have a node that's pointing to null, we can assume that there will always be a cycle that exists. How can we detect this? How can we detect if we are visiting the same node twice or thrice or many number of times? There are quite a number of ways, one of which will be to use the most common data structure, which is a hash map. So if we will be using a hash map, this approach, we will take every single node that we are currently visiting and add it to this hash map. If we start from the head, we can take this value as we visit it, we add it to the hash map that we are currently using. And whenever we go to the next node, before we add this exact node, we will check, does this exist in our hash map? If yes, then that means that we have found a loop. If no, like in this case, we will still add this exact value to the hash map again. The same will be true for the next two values. They'll all go inside the hash map. However, when we go back down this loop, we will find that, hey, the node with value 2 is already in the hash map. What does that mean? We've found a cycle within our nodes, because if at all we've found the value 2, the node with value 2 here, that means that we have already visited it before, and that must mean that we have a cycle, because how else can we visit the same node twice within our iteration? If we choose to go with the hash map approach, that must mean that our time complexity will be O of n, and our space complexity will also be O of n. However, there's a more efficient solution without using a hash map, so we will not be sacrificing space complexity in that case, and I'll take you through that algorithm as well. The second algorithm we'll look at is Floyd's Tortoise and Hare algorithm. The idea is simple. Starting from the head of the linked list, we can initialize two pointers. The first pointer will be the slow pointer represented by S. The second pointer will be a fast pointer represented by the letter F. Now, the idea is that the slow pointer will be moving one step at a time, while the fast pointer will be moving 2 steps at a time. So one thing we need to notice that if there is any node in this entire linked list that points to a null, the fast pointer will have reached it faster than the slow pointer will reach it. So if this points to a null, the fast pointer will reach it faster. However, the slow pointer will take more time compared to the fast pointer to reach it. But in this case, how do we use these two pointers to detect if there is a cycle? The thing you need to notice that while the slow pointer moves one step, the fast pointer will have moved 2 steps. So if we move these 2 pointers by 1 point, the slow pointer will be here. The fast pointer, however, will have reached this point. This is whenever we've moved these 2 pointers by 1 iteration. So if we continue this simulation, it's clear that you can see the fast pointer will reach this point faster than the slow pointer will have reached it, because the slow pointer will be moving 1 step, another 1 step, another 1 step. Now, whenever these 2 pointers intersect, whenever the slow and the fast pointer intersect, we will have detected a loop, and I'll show you in the simulation. So for the second time, if we move the fast pointer, remember, it will reach the 3, and then it will cross over to where the 3 points to. So it will come to this position. The slow pointer, however, will only move 1 step forward, so it will be here. Now, if we do this one more time, you'll notice that these two pointers will intersect. So the slow pointer will come straight to here. The first pointer, however, remember it's here. The first pointer, however, will move from 3, go straight forward up to this point. So the slow pointer and the first pointer will have intersected. So the slow pointer and the first pointer will have intersected at this position. How is that so? Remember, we stated that whenever these two pointers have intersected, we have found a loop. We have found a cycle in this entire linked list. This is because if there was any point in this linked list where any node was null, the first pointer will have caught it and it will have exited, stating that there is no loop within this entire cycle. However, if these two pointers intersect, that must mean that there is a cycle somewhere that allows the first pointer to go back within the same path of the slow pointer so that they can interact or intersect at any given position. So our condition will end whenever the first and the slow pointers have intersected. That said, let's code the solution because it's pretty simple. So we'll be using two pointers, the slow and the first pointers, and initially both of them will be initialized to the head of the linked list. Our simulation will be running provided the first pointer has not encountered any null values. We'll be checking if the first pointer is not null and the next value to this first pointer is also not null. With this, we will shift our slow pointer to be equal to its next value. Remember, we are shifting the slow pointer one step forward, but for the first pointer, we are shifting it to the next value because we're shifting it twice. Once you've shifted, we will need to check if the slow pointer is equal to our first pointer. If that is the case, then we can simply return true because we have actually identified that these two pointers have intersected and that means there is a cycle. However, if we ever exit this loop and we've not found any situation where this return statement has executed, that must mean that there is no cycle in this entire linked list. Let's run the solution, and as you can see, it's pretty efficient. If you enjoyed this solution, please like and subscribe, and I'll see you in the next one.